Hi everyone, I'd like to welcome you guys back to my YouTube channel. I hope during this December you've been safe, as a lot can happen. So, on our last video, we were looking at geomorphology. We went through all of the questions, okay, and then we finished that part. So that was 2.5, okay, question 2.5, and it was based on catchment and river management, okay. And I have to say, guys, that I need more interaction from you guys. You guys aren't saying anything. It would really indicate to me that you guys are actually watching these and are actually interested in these. If you would comment, okay, if you would let other students or family or friends know about this channel, okay. We are aiming to grow this channel, and its impact has to be great. It has to be very big. So I want this channel to help a lot of students who are struggling, a lot of students who are rewriting, students who are going to be matriculants this coming year. So it's really going to help a lot of people, okay? So I'd really be grateful if you would share this channel, okay? So just use the share button, copy link, and then paste it in your social media platforms. Okay, now enough about that. Let's get into business. We have section B, question 3, and that is geographical skills and techniques. Okay, so that is our map work, guys. Okay, now on your page you have a map of Queenstown. Okay, so we are presented with a map of Queenstown, and as we all know, Queenstown is in the Eastern Cape. Okay, so I'm just going to read through the general information on Queenstown so that we get started with the questions. Okay, so we are first provided with coordinates. So that's 31 degrees, 54 minutes south. Okay, so that is your latitude, and 26 degrees, 53 minutes east. Okay, so that is your longitude. Okay, so this is the spatial data, okay, or the location information about Queenstown. Okay, remember, spatial data, data that illustrates the location of a particular feature or area. Okay, so Queenstown, officially known as Komani, is a town in the Eastern Cape in South Africa. Okay, the town lies on the banks of the Komani River, which forms part of the Great K River system, and has a refreshing climate and an abundant water supply from the surrounding rugged mountains. Okay, the area's annual average temperature is 18.29 degrees Celsius, which is 2.93% lower than the average for South Africa. Okay, so it's quite cold. Queenstown generally receives approximately 90.83 millimeters of precipitation and has 134 rainy days annually. Okay, so that's the information on the climatology of the area. Okay, and then winters are short, cold, dry, and windy. It is almost clear year round. Okay, so you're being given information on the climatology of Queenstown, and also the geomorphology as well. If you look at the first paragraph there. Okay, so also given the type of climate. Okay, all right. So let's begin with 3.1. Okay, so begin with 3.1.1. and then look at other questions, of course. Okay, so we know that 3.1 is based on map skills and calculations. Okay, this is like the easiest part of the map work according to my knowledge. So yeah, I don't think this will be very difficult. Okay, so 3.1.1 says which human-made feature, okay, is found at grid reference 31 degrees, 49 minutes, and 41 seconds south. Okay, and then 26 degrees, 45 minutes, and 35 seconds east on the topographical map. Okay, so we'd have to first find the location of whatever human feature that is at these coordinates. Okay, it's very important that you know coordinates, guys. These are part of the map skills. Okay, so let's go on our map. In order to understand this, the coordinates, we know that we have latitudes and longitudes. Okay, latitudes run horizontally, but the way that we count, it's from the north to the south or from the south to the north. Okay, like that. So basically your horizontal lines, okay, going from north to south. So right here we are given a latitude of 31 degrees, 49 minutes, and 41 seconds. Okay, so we're gonna break that down and get to the line exactly where this coordinate is. So this means that we are going to calculate or count rather horizontally like that. Okay, so these are the lines that we are referring to. Okay, so the first coordinate. Okay, so it is 31 degrees, so that is 31 degrees, but that's 45 minutes. Okay, so this is 31 degrees, 45 minutes. There is this, so that is the whole 45 minutes, the whole 31 degrees, 45 minutes until you get to this line. Now with this line is 31 degrees, but 46. Okay, so write that down. So it's 31 degrees, 46 minutes. Okay, and this is until we get here. So this next latitudinal line is 31 degrees. Okay, we're still in the 31 degree region. Okay, so we'll get to 32 when your minutes get to 60. Okay, so this is 31 degrees, 46 minutes, 31 degrees, 47 minutes. Okay, 31 degrees, 48 minutes. Okay, 31 degrees, 49 minutes, and 31 degrees, 50 minutes. Okay, so and this is how we divide our maps. Okay, so our interest is at 31 degrees, 49 minutes, and 41 seconds. Okay, so so let's head on and look for 49 minutes. So this is 31 degrees, 45, this is 46, that is 47, that is 48. Okay, this is the whole 47, and then until you get to 48. This is the whole 48 until you get to 49. Okay, now this is 49. Okay, this is the whole 49. Okay, and mind you, this is a whole degree, right? So from 49 all the way to 50, that's 1 degree, right? I mean, that's 1 minute. Okay, so that's 1 minute. We know that 1 degree gives you 60 minutes. Okay, and 1 minute gives you 60 seconds. Okay, so that's how we know. So we know that, okay, this whole minute is made up of 60 seconds. Okay, so it's basically divided. When you divide this, it would be, you would divide it, of course, because it is making up 60 seconds. Okay, so that means that if we were to maybe count, so halfway right over here, this would be, if this is the whole 60, halfway would be 30 seconds. Okay, so 30 seconds, we know that it's halfway here. Okay, but we are looking for 41. Okay, so 41 has to be further down towards 60. Remember, this is 60 right over here. That is 0 seconds. Okay, talking about seconds right now, right? So halfway is 30, and so 41 has to be somewhere here. Okay, 41 has to be somewhere here. Okay, so 41. Okay, this will help you prevent wasting a lot of time, the estimation. Okay, so 41 has to be somewhere there. Okay, that's 30, that's halfway, so 41 has to be there. Okay, so that means our line would run like that, horizontally, like this. Okay, so that's our horizontal latitudinal line. Let's look for the longitudinal line. So it's situated at 26 degrees, 45 minutes and 35 seconds. Okay, now longitudes, they run vertically. Okay, but they go from the west to the east. Okay, so that's why they are always associated with east or west, whereas the latitudes, even though they are horizontal, but when we are counting from the north to the south. Okay, that's why they are either associated with north or south, and you always start with the latitude and then you follow with the longitude as they've done here. So our longitude is 26 degrees, 45 minutes and 35 seconds. Okay, so we know that, okay, it has to be these lines that run vertically like that. So let's look at the first line here. So this is our longitude. This is 26 degrees, 45 minutes. Okay, that is 26 degrees, 46 minutes. Okay, that is 47 minutes, 26 degrees, 48 minutes, 26 degrees, 49 minutes, 26 degrees, 50 minutes. Okay, so that's how we go. So our line has to be on the first block from the left. Okay, from the bottom left. So on the first block, it has to be here, because 26 degrees, 45 minutes. We haven't reached 46. No, it's 26, 45 minutes and 35 seconds. Okay, so 35 has to be right at the middle, or just a little bit to the right from the middle. Okay, so it has to be somewhere here. Okay, somewhere here. It has to be 35, somewhere here. Okay, somewhere here. Yeah, so that's 41 over there. 35 has to be somewhere there. Okay, so now, of course, when we intersect these two lines, that is where we're gonna get the human feature that they are looking for. Okay, so then intersect that and that. So what do you get? This is what we have. This is what we get, guys. Okay, this has to be this feature right here. Why are you blurry? Okay, so it has to be this feature, and this feature, when we look at it from the map, so that feature that looks like an L. Okay, that has to be that feature. And when we look at this feature, where is it? Somewhere here. It looks like an L. It's an L. An L. There we go. Okay, so this is it. So this is the feature, and it corresponds with rowing. Okay, it corresponds with rowing. Okay, that's what I see. What options do we have here? Options do we have here? We have A, trees. Trees are not human made, first of all. That would have been incorrect. B is spot height. Spot heights, guys, are map tools. Okay, they are like these latitudes, these latitudes and longitudes. Okay, so they are like these tools. Okay, that we use in a map. So you wouldn't consider them human made or natural made. So spot height, a ruin. There we go. So see, guys, a ruin. If you don't know a ruin is an old building. It's basically what is left of an old building. Okay, so if you had like, it's like a ghost town. Okay, you'd find out maybe there are just a couple of stones, um, you know, so just that, and like there's not a complete structure. People used to live there, but it was back then. Okay, so that's what we call a ruin, guys. It's a building that was existing back then, but that has a few materials now that represent that people were living there back then. Okay, right. So this would mean that it is a human-made feature, okay, because it is an old building, okay, that of course is now um, is now very dilapidated. Okay, it's not does not have any complete structure. There's not even one house or apartment that is clear. Okay, it's just stones. It's just walls that are of course at a very low height now. Okay, so that's what we call a ruin. Okay, D, a building. So a building, of course, would have had a building, as we know, is point data. Okay, so it would have had this square or this rectangle that is small. So that would have been a building. Okay, that's a fully complete building, but a ruin is not a complete building. It was maybe a homestead where people lived there back then, but they abandoned that. So now we just have um, the material that is left. Okay, so for 3.1, guys, I'm going with C, the ruin. Okay, I'm going with ruin. Okay, it's not only because it makes sense from these options. I'm sure some of you guys looked at these options and like, okay, trees, no, I X that out because it's not even a human-made feature. Sport height, I think you should have gotten that. It was a map tool and does not qualify as whether human-made feature or natural feature. And then of course maybe the word ruin must have maybe confused you a bit. Okay, but yeah, that's what we have for 3.1.1. Okay, a ruin, that is C. 3.1.2 says the contour interval on the orthophoto map. Okay, contour interval on the orthophoto map. Okay, so this is a Queenstown topographical map. Okay, and this is an Noid gedacht. Okay, I hope I pronounced that right. So this is an orthophoto map. Okay, so what are they saying? They're asking about the contour interval. Contour interval, again, guys, it's similar to isobaric interval. You look at the contours in this case. Okay, for the isobars, of course, you will look at the isobars. Look at the contours, and you look at consecutive isobars. Contours. Yeah, I'm sorry about that. You look at consecutive contours, and you look at the difference in value there. Okay, so that is 1,420 meters and it's always in meters, and that is 1430, 1440, okay, 1450, so on and so on, okay. And by the way, these dark contour lines are called index contours, okay. So you can even look at this, okay, you can even look at the bottom here, you have that information there. You don't have to even do this, okay. So it's provided there for you. So it's 10 meters, guys, okay. So that's how we look at the contour interval. So for 3.1.2, we're going with 10, and 10 meters is option B, okay. So 10 meters is option B, so we're going for B for 3.1.2. Let's head on, let's go on, guys. Looking at 3.1.3. So 3.1.3 says the photo number for the orthophoto map of Noid de is, okay, so photo number, you usually find it right next to the map indexing, okay. So these are your coordinates, guys. So this is your its degrees. So this information basically says that this this area or this town, it's found at 31 degrees latitude and 26 degrees longitude, okay. And this is the map indexing, guys, okay. So out of that whole area, I'm sure you guys do know these, where you have A, B, C, D, okay. So say this area is this whole area, okay. And then this piece or this photo was taken at this map index, okay. So each of these is then divided again into A, B, C, D, okay. A, B, C, D, okay. And this as well is A, B, C, D here, okay. So what this means is that out of this whole area, okay, this is the area that was picked. This is the area that was taken a photo of, okay. So it's at this index D at this area D. So that's why we say it's DD, okay, like that, okay. And it's photo number 1, okay. So DD1, okay. So yeah, that is how you interpret this information. It's very important that you know this information, what it means, because of course they are going to examine you on that. So so the photo number that we see is 1 there, okay. So 1 corresponds with D, okay. So so looking at other options, of course, that is A is 31, B is 26, C is DD, which is the map referencing, and then D is 1, okay. So of course you can see the 1 right here, okay. There we go, that is the photo number, okay. So photo number 1, so we're going with D, okay, corresponds with 1. And then the next question is 3.1.4. What do they have for us? Calculate the area in square meters of the farm labeled F in block A3. So F in block A3 in the topographical map E3. There we go. That is F. Okay, so there we go. So they want us to calculate the area of this farm in square meters. All right. Okay. What else? On the okay. Use the following measurements if the length on the map is 0.9 centimeters and the breadth on the map is 0.7 centimeters. So they are giving us the length, they are giving us the breadth. Okay, so we are given the dimensions, the length and the breadth. Okay, so we know that in order to calculate the area, we know that we use the formula length multiplied by breadth. Okay, then we calculate the length alone separately, breadth separately. Okay. So we are given that the length is 0.9 centimeters and that the breadth is 0.7 centimeters. Okay. So let's get on it then. So our length is 0.9, right? So that is our measured distance. Okay. So of course we have to calculate actual distances of this length and the actual distance of the length of the breadth, right? And then use that formula then to calculate the actual area. Okay, that's what we want. We want the actual area. It wouldn't be correct if you would just take these two, multiply them together, and then maybe divide by 100 later on, because we want the actual area, guys. Okay, that's what we're looking for. So in order to get the actual area, you know this from the distance formula, that we multiply the measured distance with the map scale. In this case, the map scale is the topographic map, which is the 50,000. Okay, so multiply this 0.9 by 50,000. Okay, and then what do? Because we want to convert from centimeters to kilometers. Okay, what we do is that we divide by 100. Oh, I'm really sorry about that. From centimeters to meters. Okay, we divide by 100. Okay, so I'm multiplying this measured distance by the map scale, then dividing by the conversion factor. In this case, it is 100. Okay, I'm doing the same for the breadth as well. The measured distance 0.7, multiply that by the map scale 50,000, and then dividing all of that by 100. Okay, so of course these zeros are going to cancel those zeros. Okay, and then what do you have left? Okay, because this is just 1, anything divided by 1 is anything, or is that thing. Then so let's multiply 0.9 by 500. Okay, 0.9 multiply 500. What do we have? So 0.9 multiplied by 500. I'm using my phone actually to do this because I don't have any. So that's 450 meters. Okay, that is our length, and then our breadth is going to be 0.7. Multiply that by 500, right? And that is going to be 0.7 multiplied by 500. That's going to give us 350 meters. And then we take these and put them on the formula. Okay, substitute them there. Okay, so the length, we know the actual length is 450 meters and the actual breadth is 350 meters. Okay, and so our answer of course should be in square meters. Okay, so that's 450 multiplied by 350. Boom, there we go, 157,500. Okay, let me know, guys, how did you guys do it? Because when it comes to these, it's either you are correct or incorrect. Okay, it's not subjective. It's always, you have to be precise on these types of questions. It's not like the paragraph type of questions where you can get away with your answer. Okay, so that is 3 marks. Okay, there we go, 3 marks. Okay, so let's head on to the next one. 3.1.5, calculate the average gradient from 6 in block D4 to 7 in spot height 1507. Okay, so we go on to 6 in block D4. So that has to be the orthophoto map, right? Yeah, it's the orthophoto map. Okay, so we're calculating the average gradient from 6 in block D4. Where's D4? D4, okay, blocks, okay. So from 6 to 7 in spot height, 1, 5, 6, 7. So from 6 to 7, okay. So basically calculating the average gradient from 6 to 7, okay. So, all right. Okay, what else? In block D2, okay, if the horizontal equivalent is 950 meters on the orthophoto map, okay. So we are told that the horizontal equivalent, so we are given the horizontal equivalent that it is 950 meters. Okay, 950 meters. That's the horizontal equivalent. Remember, we are also given the formula there. Okay, so for the average gradient, we know that we take the vertical interval, which is the difference between your spot heights, or basically the difference in height, and horizontal equivalent, which is the horizontal distance, okay, that matches that distance, or matches that height difference. So in this case, we are given as 950, right? So that is 950, and I've already written it there. So now, what's our goal? Our goal is to, of course, calculate the vertical interval, okay? The vertical interval, again, is the difference. In this case, has to be the difference from 6 to 7, okay? So the difference between 1,567 meters and 6. So 6, in this case, we going to follow this line, because 6 points to this contour line here, which is that 1,420. Okay, so 6, 1,420, and 7 is 1,567. Okay, so basically we have 1,567 subtract 1,420. Okay, and then what do we get? So 1,567 minus 1,420, and that is going to give us 147 meters. So that is our vertical interval. Okay, and then what do? Insert these two into, of course, this formula. Okay, so our average gradient in this case is VI. Our VI is 147 meters. Divide this by, okay, 147 meters, divide this by 950 meters. Okay, now what happens after this, guys? Okay, you do not put this into a calculator and then get an answer. No, that's not how you do it. What you do, guys, here is that you divide both the numerator and, so basically you divide the numerator by the numerator, divide the denominator by the numerator as well. Okay, so of course 147 divided by 147 is going to be 1 over 950 divided by 147. It's going to give us 6,46, right? Yeah. Now this is what? This is a fraction, right? A fraction, if again you watch my TikTok videos, a fraction, we know that we can write it as a ratio. In this case, it has to be 1:6,46. Okay, so, or 1:6. Okay, you can round that up to, we are not told, right? I don't think we are told. Okay, so yeah, that's fine. So can be 1:6,46 or 1:6. Okay, so That is your answer. That's your final answer. That is your gradient, guys. Okay. So for every, this means, what does this mean? This means that for every one step, or you move, for every one step you move horizontally, or 1 meter you move horizontally, you are actually moving 6 meters vertically. Okay, that describes the gradient. Okay. All right. Hope we got this, guys. I really hope so, because this point, some people actually convert it, like they just convert that, but this is how you should actually do it.